Proportional relationships. A proportional relationship is where the ratios of related terms are equal. When the graph of a linear equation passes through the origin, it is said to have a proportional relationship. It's called a direct variation equation or the parent function of lines. All lines originate from this line by being translated. Y equals mx, where m is the slope of the line. Not all linear equations have a proportional relationship. When a linear equation has a proportional relationship, then the ratio of related terms is the slope of the graph. This will be illustrated on the next slide. Families Z and A drive at constant speeds on their way to visit friends. They both keep track of their progress as shown in the tables. Let y equal distance and x equal time. Does the time and distances of either one of these trips form a proportional relationship? Plot the data from both tables to check if these are linear relationships. Let y equal distance and x equal time. The graphs are linear, but only the family Z graph passes through the origin. The family Z relationship is a proportional relationship. Family A is not. Calculate the slopes of each graph. Further verification that these are linear equations, as the slopes for each set of data points are the same. The slope of each graph equals 70. The distance over time relationship for each ordered pair of family Z's trip is equal to the slope, 70, so it is a proportional relationship. The distance over time relationship for each ordered pair of family A's trip is not equal to the slope, 70. So it's not a proportional relationship. The proportional relationship is expressed in the slope and the ratio of every y-coordinate to every x-coordinate with the exception of the origin. The proportional relationship does not exist at the origin since the ratio would be 0 over 0, which is not a real number. What is the proportional relationship shown in the graph? The proportional relationship is the slope of a line that passes through the origin. So we pick the origin as one point on the line, and we can pick this point, any random point. The slope of this line is rise over run. Rise 5, and then we run 3. So the slope of the line is 5/3. What is the proportional relationship shown in the table? Check each ordered pair to ensure that each y to x ratio is the same and equal to the slope. The slope of the line is 5/3. And you can see that 5 over 3, so here are 3 points, 3 coordinates. 5 over 3 is 5/3, 10 over 6 is also 5/3, and 15 over 9 is also 5/3. The ratio of each ordered pair and the slope of the line equals 5/3. So this is a proportional relationship. Does this table represent a proportional relationship? If it does, what is its value? We can use any coordinates to check to see if it's a proportional relationship, except the origin. You can't use the origin because you can't calculate the ratio of 0 to 0. But 4 over 2 is 2, and 12 over 6 is also 2. Therefore, this is a proportional relationship that is equivalent to 2. Does this table represent a proportional relationship? If it does, what is its value? This table does not represent a proportional relationship because 8 over 2 is 4, but 16 over 6 is 8/3. So the ratios of the ordered pairs do not equal the slope of the line. Therefore, it is not a proportional relationship. Which of the graphed lines is a proportional relationship? Graph 1, in green, is a proportional relationship since it passes through the origin and it's linear. Graph 2 is not a proportional relationship since it doesn't pass through the origin.